Hey guys, today I'm going to be solving this problem, remove nth node from end of list. Given the head of a linked list, return an nth node from the end of the list and return its head. Essentially, you're given a linked list of nodes that are so you give an n, which is going to be how many nodes are from the end of the list, and you want to remove that and you want to return the remaining list. So about doing this problem, I'm thinking that I want to create another linked list, and I'm going to set a copy of this. So, and after setting the copy of this linked list, I'm going to create two pointers, slow and fast, and these are going to be equal to my copy of the linked list. So I want to get the nth node, and the way I do that is by using my two pointers. I'm going to have a fast pointer, and I'm going to constantly set the next property of my fast pointer, and I'm going to loop through my linked list n times, setting my fast pointer each time to the next node, and then I'm going to loop through my fast pointer and set my fast pointer and set my slow pointer equal to the next node. And after doing that, I'm going to skip the nth node because I'll be reached there in my slow pointer, and then I'm going to return a copy of my linked list. So let's try this out. I have my current and a dummy node that I'm going to set to list node 0. And I'm going to set my cur.next equal to, actually I don't need dummy. I want to set my cur.next equal to head, so this will be a copy of my head. What I'm going to do now is I'm going to set I'm going to create a slow pointer, a fast pointer, and a cur pointer. And it's going to set to cur pointer, the current linked list. What I want to do now is I want to set my fast pointer to the number of nodes in my current linked list, and I'm going to set my fast pointer to length minus n, and then I'm going to, you see what I'm going to be doing next. So I'm going to set my fast pointer equal to the next node. What I'm going to do now is I'm going to loop through my fast pointer, and if it's not equal to none, I'm going to set my slow pointer equal to the next, and then I'm going to set my fast pointer to next. So what I'm going to do now is, now that my slow pointer is at the node before the nth node, I'm going to set my slow.next equal to my slow.next.next. So essentially I'm going to be skipping my nth node. And then I'm going to return the copy of the current linked list. So the runtime complexity of this would be O of n, where n is the number of nodes in my linked list, because I'm looping through my linked list once. And then the space complexity of this would be O1 space, because I'm not really allocating extra space for this. So it's faster than 23%. Thanks, guys.